So, hello there. My name is Anubhav, and I'm a software developer in Bengaluru. So, today we're going to talk about hashing algorithms. Most of you might have heard about them, MD5, SHA-256, and Bcrypt. And you might have used it at some point in your life. So, deep dive, what we are going to do is we're gonna uncover what each algorithm is all about and how do we use them and what are the pros and cons of using each of them. But before moving on, like the video, subscribe to the channel if you are new, and share it with your friends. So, let's get started. So now let's start our video. But before explaining to you what different hashing algorithms are and what they do, let's first have a overlook of what actually hashing is. So if in simple terms, if I want to explain you what hashing is, so take hashing as a black box. Okay. So what's the main functionality of a black box is you throw it a input. You just pass an input and it returns you an output. You don't know what actually it is doing, but the only thing that you know is you pass in an input and it gives you an output. Okay, so that's what hashing is all about. You just pass in one input into this black box and it returns you with a hash function, let's say 123. If you don't, and the main thing about hashing is it's easy to convert your input into an output, but vice versa is not that easy if you don't know what the original functionality of how this black box is actually performing, or what is the algorithm that is written behind this black box. So now that we have a bird view of what hashing is, let's move on to our hashing algorithms. So think of MD5 as a toy padlock. Although it's fast and was super popular in 90s, but in 2025, its speed is its main flaw. It can be easily cracked by hackers using rainbow tables and collisions. If you want to know about what rainbow tables are and what are collisions, I'll put a link to an article in the description box. From there you can go and check out what rainbow tables are and what a collision attack is. Now, the main question comes up is if it is so weak, where should we use it? Obviously, for security purpose, you shouldn't use it. So the main use case for MD5 is checking the integrity of a file. To see if the file is corrupted or not. So in that case, you can use an MD5 hashing algorithm. But if you're thinking to use it in security, then I don't think that's the best idea for you. So let's just jump into the code and see how do we implement this MD5 hashing algorithm. So let's start with our implementation. Let me first make a main method. Now we need a variable in which we will be storing our password. Now I have already mentioned this in my earlier videos also, that we don't store the password directly into our code because strings are created in the string pool memory, and due to their immutability they have a habit of staying longer in your code till they are eligible for the garbage collector. So if anyone get access to your log file, then he can easily figure out your password, and it's readable also. But for the demonstration purpose, I'll keep it in the password variable only. Now, what we need to do next is we'll define an instance of message digest. So message digest is a class in Java that provides us with algorithm to compute cryptographic hashing. So we'll first create an instance of it. So message digest dot get instance of MD5. Okay, now, okay, what's the error? Okay. So we have to add the exception signature to the method. Now what we're gonna do is mm, MD5 creates a 128-bit bit hash function, which is equal to 16 bytes. But it gives us in a hexadecimal format. So we need to store it in a byte array. So let's just define it a byte array and just name it hash bytes equals to md dot digest, and we have to pass the bytes of this get password method. Now, as I told you that it creates a hexadecimal format, so it's not readable by the eye. So in order to make it readable, we'll first define a string builder class. Let's be equals to and next we'll loop over over each byte in this hash byte. Then we're gonna append string. Now we have to format it into a hexadecimal format. So let's type in, where's the percentage, 0 for padding, 2 for width, and X for hexadecimal byte. So as you can see, I'm formatting it, and if I explain to you what this format is, so percentage stands in Java for like we're gonna start our formatting from this part. Two, we are padding an extra character because we want each byte to be of length 2, so it's kind of a width, and X stands for hexadecimal. So if I give you an example to relate this is, so if you take 15 in hexadecimal format, lowercase alphabetical, we take lowercase alphabetical orders to represent the hexadecimal format, hexadecimal number. Okay, so it's for 15 we take it F, but we have specified that we want a width of 2 for each character, so it will append 05. So if there is 15 in our hash byte, then it will be converted to 0F. Okay, cool. Now let's just print it out. So we'll do sout sb dot to string. Now if I just run this code, it's building. Sorry, my bad. Okay, so now you can see that this is our hash value. Although it has created a very short hash, but it has taken a like a shorter time, but like it was very fast, and that's the main flaw with it. So yeah, that's it for the video. This is Anubhav. You are watching CodeSpark. Signing off. Till then, take care and keep hashing.